presentation. All right, so I'm going to start right now. Hello, everybody. Good day. My name is Camilo Diaz. I'm a graphic software engineer for the Center for Computation and Visualization here at Brown University. I'm part of the 3D visualization team, which is a division between this large group of researchers and data scientists, but we are in charge of building tools and applications for 3D interactive applications. The first part of this talk, I'm going to briefly explain what we do as a team, and later on, I'll go with the remote rendering example. But first, I think it's very important to introduce what we do here at CCV, here at Brown. So basically, the group is me and Robert Hedma. He's over there. So what we do is just building applications to display scientific data in 3D on multiple devices. So we got multiple applications working. The same application we can translate into multiple devices, such as the PC monitor, a VR headset, and a cave system. We do have experience porting these applications to multiple devices, to multiple environments, regardless of the requirements for what is needed. What is the kind of data we have worked with? Well, usually the data we have most experience with is the volumetric datasets. Volumetric dataset basically is just represented as a stack of 2D TIFF images. Basically, what we do is just doing rendering passes, volumetric rendering algorithms in order to just display on a computer graphics environment. We also do have work with triangle meshes. Go for it. I unmuted.
You want to unmute yourself, though.
Are you sure? Am I good now?
Yep.
Good. Perfect. Sorry about that. Where was I? Yeah, so we do have experience with volumetric datasets. Triangle meshes are basically described on OBJ files. Those are basically files where it represented the vertices on a position on a space world coordinates. And we also have experience with point cloud data sets, which are basically the results of 3D scanners and photogrammetry software. What basically does is just measuring points on all the environment that is surrounding them. We also have experience with that. These are some of the divisions here at Brown that we have worked with. We work with the computer science department, biomedical engineer, pathology and laboratory medicine, the Multimedia Lab, the Rhode Island Discovery Center, and University of Minnesota. We have done several applications with them in the last 4 to 5 years. This is some of the applications we have actually built here at CCV. So the first one, this one right here, what we do is simulations for different hearts. We translate that into virtual reality, into the Oculus. This is a data set given by the biomedical engineer here at Brown University from Karim Coulomb. We also have, I believe this is one of the most popular applications here at Brown, is Drone Air. It used to run in the old jar. This is basically an application that uses haptic algorithms. Those are basically devices that have 6 degrees of freedom, and you can actually draw on a 3D environment. If you are interested in taking a look at it, I have a small demo right here. At the end of the presentation, you can take a look at that. And the last one right here, this one is an experiment from John Cayley from the Visual Art Department. What they do is just trying to translate poems and to virtual reality. It's like a fun experiment. I also have it here in case you want to take a look at that. So it combines animations with music, and they try to tell a story inside a virtual environment. It's a really good experiment. I like it a lot. just a brief, these are brief examples. So we don't only work as I labeled it right here. This is the kind of software we have worked with. We have worked in Unity and with C++. But we also have worked with A-Frame. A-Frame is this library in JavaScript that allows you to do 3D rendering on web browsers. So that means that you don't have to download and install an application, a C++ application, or you have to build your Unity game in order to distribute it to all the people that are interested in your application. For the A-Frame case, what you basically do is just build this simulation, and you can just upload it, and anyone with a web browser can access to that simulation. So this is one of the best examples we have right now. This is volumetric data given by the Rhode Island Discovery Center. This is supposed to be part of the Narragansett Bay. Here, this is all based on A-Frame. This is just a public URL. Everybody, anywhere in the world, have access to it. On this example, what we got is different measures for the salinity and temperature on different times in the year. I think it is 2018. So let's, for example, right now, this data set is salinity. Let's change it to temperature. There's difference, and you can also play with the transfer functions. Transfer functions is just applying different colors to different values in the data set. So as you can see on this example, we're measuring the temperature on the summer with low tide. And you see that it's actually quite warmer here in the bay. The Providence should be somewhere around this area. We also have data for the winter, and in winter it can be showcased that it's colder. This is pretty interesting. This is a project that it took us a while to implement, but I'm really proud of it. There's another example we got here. This is basically mini brains given by the Center for Alternative Animal Testing here at Brown University. What they do is just grow up artificial tissues on animals so they can just test, just remove the animal part for testing on different drugs and different kind of cosmetics. On this opportunity, we have, this is volumetric data. Again, this is a set of TIFF stacks. And this is basically a combination between two different stains in the mini brains. So let's see if, yeah, I got it right here. So we also built this application, and we got two different stains right here. And right now, these two data sets are combined, but we can uncombine them just to show you that those are two different data sets. We can just turn it on, turn it off, and we want to combine them. Oops, I turned on both. Turn off. This is very exciting. I don't think there are many tools nowadays in the world that are able to do that. This is custom made here in Brown University. Just contact us if you have any special case that you can use this right here. You can also play with the axis planes, and you can see the internal structures of these data sets right here. Zoom in, zoom out. That's very interesting. There's another application, another example that we have built for the Rhode Island Discovery Center again. This is a simulation of the animation on what happens related to temperature in the Narragansett Bay. So let me run it for you. So as you can see, we we also have the terrain. We added the terrain to the Narragansett Bay volumetric dataset, so we can just make it look more realistic. So, and plus we added a couple of points of interest. So people can identify several points here in Rhode Island, and they can play with the volumetric dataset. Sure.
So can you look at, like, because it's volumetric, can you look at the temperature at like a given depth?
Yes, correct.
Oh, cool. Okay. That's fun.
We got this application working on 2D, virtual reality as well. I'm pretty sure that it can easily port to the cave as well. Let's continue. As I explained before, we also have working cave painting, which is the 3D, the draw on air example that I got right here, just in case you want to take a look at that. The hearts application, I also have it right here for the small demo in case you want it. But all right, so let's continue. There's one additional thing that I'd like to mention here. So probably most of you don't remember, but we used to have this huge virtual reality theater called the Yard, which is composed like from 69 projectors that will give you like a real 3D experience, an holographic display system. We translate part of that technology to a different cave. We already finished setting it up. All the configuration steps have been completed, and what we do is we just want to bring more people to these kind of technologies so they can build their own experience, their own applications. You can call it games, you can just call them displaying scientific data. But one of the main, nowadays, one of the main softwares are the game engines. So the most popular right now is Unity. And Unity is really easy to use. People make games on Unity all the time, but we want everyone to be able to just work with Unity so they can just produce their own content. And also, we have poured Unity into the cave system that I mentioned. This is basically the configuration that we got for the cave system. Is a multi-display, stereo rendering. You don't have to wear those heavy headsets on you. It's just a small pair of glasses, and you get the whole 3D experience. I got a few pictures right here. It's fully functional with Unity. The only thing that you need to do is you just need to know how to build content in Unity, and we can help you porting it to VR headsets and to the cave as well. So just to remind you that we're gonna do a few workshops on Unity. One is gonna be hosted by my colleague Robert this Monday. Everyone is welcome to join. We're gonna show you how to work with Unity, how to export, how to build your applications, and also we're gonna have a VR hackathon. This is gonna be the 18th of this month. So yeah, everything is just moving to Unity. We want everyone to be able to build your own content, being able to showcase it to anybody that goes to the cave. It's a place that it really needs to be used. Yeah, so everyone is invited to it. I believe that an important collaboration that I haven't mentioned so far is working the Multimedia Lab. The Multimedia Lab, they work here. They are located here in the Granoff building. They have multiple headsets. If anyone is interested in borrowing one of them for their own personal experiences, for building their own content, they can just go and talk to them, and they can just borrow an Oculus Quest 2. So just to keep it in mind, they're a nice group of people that are willing to help you on anything you guys need. All right. Having said that, just email us if you want to have. If you have any questions, you're welcome to come. Now I'm gonna move to remote rendering. I'm gonna start by. Everyone knows what a GPU is. I would like to just go a little bit deeper on what GPUs have brought to our world nowadays. GPUs are basically have the ability of parallelize jobs, making it high performance. You can just run a lot of jobs at the same time. The GPU doesn't have the same amount of tasks of jobs assigned to the CPU. So nowadays we got just plenty of new applications that have been built with the modern GPUs. We got these super cool ray tracing examples. We got movies. We got video games they look basically real. And most of it we have seen this explosion on AI research and applications. Everything is thanks to all the research and advances on GPUs. So we got the deep learning examples. The AI can play video games. They can translate from basic pictures to more complex ideas. That's really impressive. Something that we didn't see back in the 90s, I guess. But I'm really glad that we have advanced so far. One of the good things here at Brown University is that we got this system called Oscar. Probably no one knows it yet. But Oscar is this huge supercomputer cluster system with a lot of nodes. They have several GPUs, and everyone can just go and work with them. They can just require an account. They can produce their own CUDA code, their own research. This is basically this is a little bit old, but these are the GPUs that are available on Oscar right now. I mean, the P100 is the one that I use the most, but yeah, we have different clusters. Well, you have access to different kind of GPUs for multiple works you want to do. So these GPUs are incredible. They do a lot of things, but they are specialized on scientific research and AI and deep learning. But I mean, G is for graphics, right? This is a graphics process unit. Why not using them for graphics? Doesn't make sense, right? Or probably it makes sense. Maybe they just should rename the GPU. But let's use them for rendering after G is for graphics. So, what is the main case? What is the main user case here for distributed remote rendering? So, specifically for scientific data sets, sometimes the data sets are extremely large. We have seen cases in CCE where a single data set is over 300 gigabytes. There's no way that's going to run on a single computer. Or maybe if you have a supercomputer, it will do it. But the big idea behind that is like, we have this cluster of multiple nodes, so maybe we should do something about that. Maybe it's a good idea to distribute the data sets. And that is something that we're doing here at Brown. So we have the tools in order to do this. So a couple of years ago, we did this experiment that it worked perfectly, and we wanted to just make it available for everybody here. So how does it work? Basically, what we have is, if you have a large data set, I said large data set is over the 20 gigabytes nowadays. Maybe at 10 gigabytes, your computer starts slowing down. But those are the perfect cases for using the remote rendering server. So basically, we have something called the orchestrator, and the orchestrator is called ParaView. It's the scientific software called ParaView. What it does is every time you're telling to render a specific data set on the remote rendering server, what it does is just, oh, the pizza is here. So Yeah, so what Paraview does is just distributing this large data set of multiple nodes, and those multiple nodes are in charge of rendering their specific part of the data set, and the orchestrator, what it does is just trying to understand the big picture. It just pastes everything together and just says a single image to the client of the resulting image. This works for static data sets and also for animations. We don't have the animation examples, but we have seen it working, so just to let you know. As I explained before, we're using Paraview to do this, to build this experience right now. Right now we're working with Paraview 5.9. Maybe a couple of questions that you have is, do you need Paraview installed on your computer? Yes and no. I'm going to give you an example of how to run it from Open On Demand. I tested an Open On Demand and it works, and how to run it from a local Paraview installation. You guys go for this, all right? Let's pause the presentation for 5 to 10 minutes.
The zoom bar because it's blocking some of the images.
Thank you.
And then
Okay, let's continue here. All right. Uh, so far, if there are any questions, just let me know. All right. A few questions can appear right now. As I mentioned before, you need to be an expert on ParaView. No, but if you want to do something more leverage, something with, you have to analyze your data set, you want to segment your data sets, yes, then you need to just learn a little bit of ParaView. We can help you too on that. There's nothing we can help you with, just a small case where we can, but we have a few experience with ParaView as well. So yeah, here is just the basic demo on how to start up the server. It's already working for everyone to test if you guys want it. Just to continue on this topic, one of the most important steps for remote rendering services is to allocate the resources. And if you have some experience with Oscar, you actually have to queue. You have to just submit jobs. You have to submit to Oscar in order to give you the resources that you need. Is exactly the same case here in remote rendering, but in this specific with this specific case, we have built a general pipeline. We have built scripts that you don't have to do much. You just have to tell Oscar that you want to get the remote rendering server for you, and it will automatically allocate the resources for you, and it will send you an email when the resources are ready to use. The email has all the instructions that you need in order to connect to the server. So there are few chances for you to get lost on any of the steps. This image right here is basically the pipeline that we built for users. So basically what you have to do is just connect to Oscar. Nowadays you can do it by terminal, SSH. You can also do it with Open On Demand. I'm gonna do the example using Open On Demand so everyone can do it with me if you want. There's a specific module you need to load, which is ParaView 5.9. I'm also gonna do that. When you execute the command, Oscar is gonna take the request and he's gonna allocate the resources for you, and then he's gonna send you an email with, hey, the service is ready. It's up to you to connect. You have like 2 hours, and between those 2 hours, you have to connect to the server and do all the work you guys need to do. All right. So let's do the demo right now. So let's assume this is my first time doing this, and let's do this. All right. All right. Open On Demand. The first thing that you need to do is just access Oscar through a terminal. And let's do that on Open On Demand. So we open On Demand, we go to the Clusters tab, and you do click on Oscar Shell Access. And that gives you a terminal that is connected automatically to Oscar. Easy, you don't have to do anything much. And then you do module load ParaView 5.9. That's the current version we support. Yeah. Please don't combine this. The client needs to be 5.9 as well. This is the version of the server. Don't try to combine different versions of ParaView. It's just not set up for that. All right, so the model has been loaded. Now, all you have to do is, we also have in the Oscar documentation, it's also explain all the structures that you need to do in order to run the remote server. This is the set that I just did, which is loading the model. And all you have to do right here is just running this command right here. Oh yeah, I'll go to open on demand. Right. So run remote server is the command you want to use using the flag -u. That's the most important flag for this command, because that flag is telling the script the email it needs to send. It's going to send an email, and that's the email account that is going to be sent, informing that the server is ready to use. So it's very important that you actually fill this part correctly. So this is my email, right? And I only need to run enter. And it says confirmation email sent to Camilo Diaz, right? Now I need to go to my email. And you see I just received an email right here that it says that the ParaView connection is ready. And it's telling me that the connection is available from this time to the other time, and just make sure to use it on this time frame. Please use ParaView client 5.9. On this moment, I'm gonna do using my local ParaView 5.9 installation right here, correct? And I'm gonna follow all the instructions right here. So the first, if I want to communicate with Oscar from my local machine using the remote rendering server, I need to use something called the tunneling. So all the instructions to create a tunnel connection to Oscar are right here. On this specific case, this is the only command. It says that I need to copy this command. Let's go to a PowerShell. Let's do a terminal console. Yeah, I'm using Windows, but the same should work in any other operational system. If I follow the instructions, just remember that this part right here, your Brown ID, this is not the same as your email. This is the same username that you use for connected to the Brown to any kind of Brown service. It's the one that you use for connecting to the Brown or wireless network. So on my specific case is it's going to ask you for credentials, and we have to use the duo push. So I'm just confirming that I'm going to use the service. It has been approved. So this is what is actually normal. Nothing. There's no error. It's just right there. It's going to show an error. In fact, when there is an error, it tells you that there is an error. But if nothing happens, if it just stays there, then it means that the tunnel connection works. All right, let's continue with the instructions. So I want to connect from my ParaView client, from the one that I have installed here in my machine. So I open the ParaView 5.9. I go to connections. I add a server, and let's follow the instructions. And let's call it add server, and let's do remote rendering. Let's name it remote rendering. And it also says the name of the host is localhost, right here, and the port is the one given right here. All the information you need to connect to the server is in that email. Don't forget that. You do configure, manual, and then you select the server and you do connect. Don't pay attention to this error right here. What that error is telling me that the Python version that I'm trying to connect with is completely different than the one that I got on my computer, but you can ignore that error. Unless it says connection reset or can't find host, then I should be concerned, but not on this point, not at this moment. So as you can see at the right side of the screen, I can see the Oscar node that I'm connected with. At this specific moment, I connect to the GPU 1207, right? This is good. That means that we are connected. Now, let's load some data set right here. Yes, this one. This is a 2 GB data set. Let's load it and see what happens. It might take a while. That's an excellent question. The script is a local script, but the data set is in Oscar, meaning that in the script, I'm telling it to go to a path that is in Oscar. In fact, when you're already connected to the remote render server, you're supposed to be in the Oscar file system. At this moment, ParaView is connected to the Oscar file system. If you do, I'm going to do the I'm going to show you what happens if you click on Open right here. It will show you the Oscar file system. All right. Well, it finished, it loaded, but you just find yourself seeing this line right here. So what does this mean? It means that ParaView, they have the policy of not overusing the memory as much as they can. So most of the time, they just reduce the amount of memory they have to use every time they load a data set. So this is like it's telling you that the data set is there, but you don't see it. Why? Because we have the visualization mode as an outline, but we want to see the volume. You just do this, it tells me, hey, this is going to take a lot of resources to load. You want to do it? Yeah, of course, we're connected to a remote render server. We don't have to worry about that. Just hang on, be patient. And as you can see here at the right side, you see the memory use, the use memory and the disk usage in Oscar. It seems that it finished. Yeah, and it's right here. And ta-da! This is being rendered not from your computer, but directly from Oscar. Oscar is the one doing this rendering for you. This 2.3 gigabytes data set. Now you might ask what you can do here. Well, we like to play with the color map editor, right? And let's see that we want to Oh, this is funny. Well, this is just to modify the transfer function. What you can do is just map different colors into the data set, and you can see that the visualization gets affected depending on how the transfer function is being defined. You see? You can just set points, and you can just move it, and you can modify the transfer function. There you go. You can keep playing with that transfer function all the time you want. And because the connection is extremely reliable, Oscar has been improved a lot. It's reliable enough, and this is really good. So this is on how I connect from my local computer, but what if I don't want to have ParaView on my, what if I don't want to install ParaView in my computer? Well, I can just do everything in Open On Demand. Let's do that example, that short example in Open On Demand. So here, let's go to Open On Demand. So because I canceled, I deleted the data set and I canceled the job, I have to resubmit a new one. But that's easy. I just run the same command again, run remote server -u and my email address. It's going to send me a new email, and anytime, there you go. There you go. I got a new email with all these instructions. If you go at the bottom, it tells you how to connect using Open On Demand or the old BNC. And what you do is then just open the desktop. let's wait for the resources to be allocated. There you go. There you go. Now, if we follow the instructions, we need to open the terminal. Oh, no, not this terminal, because we already did that. Well, yeah, let's open it there. Let's load ParaView, find 9, and then you do the command. I think it's UI. Give me a sec. ParaView find 9 UI. And that automatically opens ParaView find 9, which is the version compatible with the remote render server. And let's do the same process. Let's continue with what the email says. It says that I have to go to Server Connect, and I have to. This is the host that I'm going to try to connect. Again, I'm adding a new server right here. I'm going to call it remote server. The host is the one that the email is telling me to point at, to copy and paste, and also go with the port. Manual, save. You do connect, and ta-da, the same error happens here. Just ignore it. But here we connected to Oscar, and let's load the same data set. Come on. Does it take this long? Not really, but again, as you can see, the same outline, exactly the same what happened in my local installation. I just need to change the volume. Yes, and wait for it. Let's wait for that. Volume rendering is not something cheap to do. It takes a lot of rendering passes. It could take a few resources. Well, yeah. This is the data set again, but this time loaded from Open On Demand in Oscar, so you don't have to install ParaView find 9 in your computer. This has been tested on multiple operational systems. It was tested on Windows, Mac, and Linux, on an independent Linux box, and here in Open On Demand. So yeah, this is the servers. Everyone is welcome to use it as much as you want. Let us know if you have any conflicts, any issues. And yeah, this is pretty much the end of my talk. Thank you for coming by. If you want to take a look at a small demo of the applications we have built here at CCV, just approach here to my stand. I have the VR headset here. And yeah, this is pretty much it. Thank you so much. If you have any questions, go for it.